last topic for this chapter, but the last topic for today. Okay, so now you see the remainder theorem and the factor theorem. Okay, we can explain. Now we go. Now I explain first about the remainder theorem. Okay, we have the polynomial fx. Okay, always we let the polynomial. Okay, let's say as x squared plus 3x plus 1. Okay, this is the polynomial. We call this as a polynomial and we let it as fx. And then we divide this polynomial by a divisor which is x minus 3. Okay. Okay. As you can see from here, divisor is a linear equation. So when you divide x squared plus 3x plus 1 divide by x minus 3, we can see that by remainder theorem, if the polynomial is divided by the linear divisor, the remainder will be f. This is your remainder. Okay, please refer back to the question that you did just now. Okay, question D. Okay, question D, you see your remainder is negative 91. Okay, the question about the polynomial is, what is the polynomial for that question? Can you read for me? 3x cubed plus 2x minus 4. Okay, divide by, what is the divisor? X plus 3. Okay, now you see this is our polynomial and this is our divisor. And you see your divisor is a linear equation. Now this remainder theorem only referring to the linear equation. Okay, now your divisor is linear equation. So by long division, you get your quotient as quotient. Quotient berapa? 2x squared or 3x squared, louder, 3x squared minus x
9x
plus
plus 29.
29. Okay, this one is negative 9x. Okay, your remainder, this is quotient,
Negative 91.
remainder is negative 91. Okay, now by remainder theorem, this you find by using long division or synthetic division. Long division or synthetic division. Okay, by remainder theorem, as mentioned, I see that if you have a polynomial and this polynomial is divided by the linear equation, so remainder directly you can find f, because the linear this one is x plus 3 equals to 0, so x equals to negative 3. We substitute the value of the equation inside the polynomial, negative 3 and 3, negative 3 cubed plus 2, negative 3 minus 4. Okay, so negative 3, okay, here you can get negative 91. Right. Okay, without using long division. Okay, let's say the question asks you to find the remainder. They give you this. They give you the question, which is they give you a polynomial and they give you a divisor. So sometimes they just ask you find the remainder. Find the remainder. They don't mention about long division or synthetic division. They just say find the remainder. And you see the pattern. Oh, this is a polynomial and this is a linear equation, not a constant, not a quadratic. This is a linear. So I know by remainder theorem, I can get my remainder by substitute the value of this divisor inside the polynomial. Then I can directly get my remainder without using this long division or synthetic division. Is it right?
Yeah.
Okay. This is referring to the this is referring to the factor theorem. Okay. Okay, x cubed plus 2x plus 3. This one. Now we go to the factor theorem. Okay, we have the polynomial which is f(x) equals to x cubed, sorry, x squared, x cubed plus 2x plus 3 and divide by the divisor is x plus 1. Okay, x plus 1. Okay, you see now you have the polynomial and you have a divisor, and your divisor is a linear equation. So by you recall back, by the if the question asks you to find the remainder, okay, by remainder theorem I know, I just substitute, I find the value of this divisor which is x plus 1 equals to 0 and x equals to negative 1, and then I just substitute inside the polynomial, then I can just get the remainder which is f negative 1 cubed plus 2 negative 1 plus 3, which means this one is negative 3 plus 3 equals to 0. Oh, now I get 0, which means it's referring to the factor theorem. So what is the importance of the factor theorem? Which is we want to clarify this as a factor of this. Okay, now I just want you to recall back, what is the difference between factor and root? Factor and root. Apa beza? What is the difference between factor and root? Root of equation. What is the difference between factor and root? What is the difference between factor and roots? Ada dua. What do you mean by dua? Dua jawapan. Okay, tak semestinya dua jawapan. I know you're referring to the quadratic equation, which is factorization or quadratic formula, then you get that value. Okay, that value which mean this we call as a root. This we call as a factor. Okay, now this answer my question just now. What is the difference between roots and factor? This we call as a root, this we call as a factor. So when you substitute the value of this, you get 0. So I can say that this is a factor of this. Factor tu maksudnya macam remember back the quadratic equation. X plus 1, x plus 3. Okay, we multiply this, we get x squared plus 4x plus 3. Okay, now you have this quadratic. Let's say you only have this equation which is x squared plus 4x plus 3. Okay, if I ask you to find the factor, find the roots, or solve this. Solve means find the roots. Okay, you will, using the factorization or quadratic formula, you get this pattern, which is just now x plus 1 and x plus 3. Okay, this we call as a factor. Factor, when you multiply these two factors, you get back your quadratic equation. Okay, from factor you can find your roots by letting x plus 1 equal to 0, then you get your root as x equals to negative 1 and then x equals to negative 3. Okay. Okay, so now you understand what is a factor. What I say, when we substitute